Hello everyone, in this video we will go through review notes for chapter 5. In chapter 2 we briefly learn about normal distribution, and normal distribution is the most widely known and used of all distributions. It is symmetric, bell or mound shape. I already have the curve drawn here, and it's continuous for all values of x between minus and positive infinity, and which basically means each conceivable interval of real numbers has a probability other than 0. Note that normal distribution is actually a family of distributions, since mu and sigma as standard deviation determine the shape of the distribution. So basically, we know that the bigger the sigma gets, the wider would be the curve, and as the sigma decreases, the curve will be also pointier. Also, this is the density function to get the in order to get the normal distribution. We also learn about empirical rule in chapter 2, so this is an overview again. We know about 2/3 of all observations fall within one standard deviation of the mean, or we can also say the probability that x falls between mu plus minus 1 sigma is about 68%, and the probability that x falls between mean plus minus 2 standard deviation will be 95%, and the probability that x falls between 3 standard deviation and mean will be 74%. Here there's a new term we learned about. It's called standardized normal distribution. Standard normal distribution is basically just a normal distribution with mu equals 0 and sigma equals 1. Random is a random variable with the standard normal distribution. It also denoted by z, and it's called standard normal random variable. We can calculate z value by subtraction of mu by from x divided by standard deviation, which is normally distributed, with a mean of 0 and a standard deviation and variance of 1. Also, we can refer to table 2a as a table of standardized normal values. Also, if necessary, we can convert back to the original units of measurement. Here we can use this formula to get the x through z value, standard deviation, and mean. Here's an example. The top 5% of applicants as measured by GRE score will receive scholarships if GRE is normally distributed with a mean of 500, I already have it here, and variance of 100 to the power of 2. How high does your score have to be to qualify for a scholarship? Basically, we're looking for x, the value of x, which already talked about it, how to calculate. It's z cubed plus mu. So if we have the distribution, have the normal distribution, because it already mentions normally distributed. In order for the score to fall in top 5%, will be this area of the curve. So we can basically use z table to calculate the area to the left, basically lower than 5%, which is 95%. we can get the z-value for 95% of the area. Here we have the positive z-score table, and I already circled the value closest to the 95%, which is corresponding to 1.65 as a z-value. We can simply put z-value 1.65 times standard deviation 100 plus mu, which is 500, the mean. So the score has to be 665 at least in order to fall in top 5% to receive the scholarships. Thank you so much. We'll see you in the next video.